Hello everyone. So today I will deliver you lecture number 3 from the organic chemistry chapter, which is aldehyde, ketone and carboxylic acid. Okay. So in my last class I have discussed aldehyde, ketone mainly. So today we will start carboxylic acid. Well, carboxylic acid, as in my first lecture I discussed with you, they are weak acid as compared to inorganic acid like hydrochloric acid, nitric acid, sulfuric acid. So they are organic acids, but they are having weak acidity. Okay. So what is the formula of carboxylic acid? As all of you know very well, RCOH. So this is the formula of carboxylic acid. Now the important thing is why these carboxylic acids are acidic in nature, right? So as you know, in Arrhenius concept, any substance which gives hydrogen ion in its aqueous solution is an acid. So carboxylic acid, if you dissolve in water, then you will get carboxylate ion and hydrogen ion. So from that point of view, we can tell that carboxylic acids are acids. Moreover, this carboxylate ion, this RCOO negative, is stabilized by resonance. It is what? Stabilized by resonance. So whenever you dissolve carboxylic acid in water, then it will form this hydronium ion and it will form this carboxylate ion, which, as I have already shown here, it is stabilized by resonance. Here this RCOO negative, for example this RC negative, this electron can go to this oxygen, then this electron will come to this oxygen. So you will have a what? A resonating structure. Now this electron, and whenever this electron comes to this carbon, they will make the double bond, and now here this bond will open to form a single bond, and here two electrons were already there. Now this electron and this electron will come and ultimately you will get a negative ion. So this negatively charged oxygen is called as carboxylate anion. Right. Now if any system stability is achieved, then equilibrium will always try to shift towards the what? Stable side. So you can tell that when you have carboxylic acids and water, this carboxylic acid will be dissociated to form carboxylate anion, and hydrogen ion will be also produced at the same time. Now since it produces hydrogen ion or hydronium ion, so carboxylic acids are acidic, right? So again, you know very well, if any substance is acidic, then pH will be what? Low, because the formula of pH is what? pH is equal to negative logarithm of what? Either you can write hydrogen ion concentration, or you can also write pH is equal to negative log 10 of this hydronium ion concentration, right? So here we can see this hydronium ion is formed. So this hydronium ion, if this hydronium ion is formed in greater amount, acidity will be more, right? And if this hydronium ion is formed in greater amount, acidity will be more. And if acidity is more, then a negative sign is there, so pH will be less. Right. So this hydronium ion if more, then pH is less, and if pH is less, acidity is more, right? That's why these carboxylic acids are acidic in nature. So in other words, here I have shown that K is equal to this I'm going to show in the next slide. For example, see this RCOOH, right? Whenever you add water aqueous condition, this RCOOH will dissociate to form RCOO negative plus H positive. Now the equilibrium of this constant of this reaction can be expressed by this formula. RCOOH. Now as I discussed with you that if hydrogen ion concentration is more, that means equilibrium will shift more towards right, acidity is more, and in that case you can also tell that the dissociation constant Ka is also more, right? Now another important point is what is pKa? As I discussed with you, pH is what? Negative logarithm of hydrogen ion concentration. So we can also tell that pKa will be what? Negative logarithm of log 10 of what? Ka. Now more is the value of Ka, more will be the what? Dissociation constant, that is Ka, and consequently pKa will be what? Less, because a negative sign is there. So if this quantity is more, that is if Ka is more, then pKa is what? Less. So we can tell that if the dissociation constant Ka value is high, then pKa will be low, and we can also say at the same time acidity is also high. So this is a very important thing. Acidity we can measure with the help of two parameters, either pH and another one is what? pKa. So if this pH is less and pKa is also less, then we can tell that acidity is more, right? Then acidity will be more. So from that point of view, we can consider that if any electron withdrawing group is present in the carboxylic acids, so it will further stabilize the carboxylate anion. At the same time, if this carboxylate anion is more stable further, then Ka will be more, and if Ka is more, then what? pKa will be less, and if pKa is less, then acidity is also more, right? So any electron withdrawing group in the carboxylic acid part can increase its acidity, while any electron donating group can what? Destabilize the carboxylate anion, and ultimately acidity will be less. So this can be explained with the help of one example. For example, if you can take CH3COOH, right? This is one acid that is called as ethanoic acid or what? Acetic acid. But if you have an electron withdrawing group to this carboxylic acid, then its acidity will be what? More, because this chlorine is a what? Electron withdrawing group or electron negative element also, we can tell, right? So presence of electron negative element or electron withdrawing group can enhance acidity. So chloroacetic acid will be much more stronger acid than acetic acid, right? So then you can tell that presence of electron donating group can what? Decrease the acidity. For example, this is called as formic acid. In IUPAC system it is called as methanoic acid. Now here this is what? Acetic acid, or in IUPAC system we call it as what? Ethanoic acid. Now here you can see that plus I effect producing group is there. So plus I effect producing group is called as electron donating group or electron pumping group, which can decrease the stability of the carboxylate anion, and ultimately the acidity will be low, because as we already know that if the Ka value is more, then acidity is more. If the Ka value is less, acidity is less. Okay, so this depends on the what? Dissociation. electronic effect is related with the dissociation of the carboxylic acid. So if the electronic effect is a minus I effect, acidity increases, and if the electronic effect is a plus I effect, acidity will decrease. Okay. For example, so another example is there. Here you can see this alcohol is what? ROH. Now if you dissociate into water alcohol, you will get what? Alkoxide ion. And if you dissociate phenol, you will get what? Phenoxide ion. And if you dissociate carboxylic acid, you will get carboxylate ion. Now among these, carboxylate ion is what? Much more stable as compared to what? This phenoxide ion and obviously alkoxide ion. So we can tell that carboxylic acid is much more stronger than phenol, and even phenol is much more stronger than alcohol. Now the question also you can write, so how we can explain about the stability of alkoxide ion, or how we can relate the acidity of alcohol? Well, again the same concept we can apply. For example, suppose so for example, alcohol, if you dissociate into water, it will form this RO negative, that is called as alkoxide ion, and it will release obviously a proton. But important thing is what? Here there is a plus I effect, that is we can call it as what? Electron donating group. Now this plus I effect, due to this plus I effect, the negative charge of this oxygen will increase. So if one thing you always remember, if the charge is more, reactivity is also more. If the charge is less, reactivity is less. So you can tell that here already oxygen has negative charge, but this is an electron pumping group, that means it will push the electron towards oxygen. So the negative charge of oxygen will increase and it will what? Destabilize. So this alkoxide ion, we can tell that alkoxide ion is unstable due to what? Plus I effect, right? So this is very important. Whereas if you can see carboxylic acid, if you give in a water, then it will form what? It will form this what? Already I explained you, carboxylate anion, right? Now again I discussed with you that this electron can go here and this electron can go here. So ultimately you will have a resonating structure where the electron will come from oxygen to oxygen. So this electron can come into this and ultimately it will reaches to this what? Oxygen. As a result, both this oxygen gets partial negative charge, right? So both this oxygen will get partial negative charge. So you can tell that if the charge is dispersed, that means what? The repulsion will decreases, and if the repulsion decreases, energy of the system also decreases. If energy of the system decreases, stability always increases, right? So this carboxylate ion is what? Stabilized by resonance. So that's why this equilibrium will more shift towards the right hand side and you will have more hydrogen ions, right? So that's why carboxylic acids are acidic. Now the question is what? You can ask that also, what will happen in case of phenol? Phenol also in its aqueous solution form phenoxide ion, which is stabilized due to what? Resonance. So the negative charge will be dispersed. But the interesting thing is, in case of phenol will be also acidic, but it will be weaker acid as compared to carboxylic acid. Why? I will explain in the next slide. But one thing you always note that here in case of carboxylic acid, there are two electronegative oxygen atom. So there is strong electron withdrawing effect. And in case of phenol, only one oxygen is there, and phenol is stabilized due to what? Also due to stabilize due to resonance. But no such effect you will get in case of alcohol. So one thing we can sure that alcohol is what? Weakest acid. So as I have shown here, among this acidity will increase. So carboxylic acid will be stronger than phenol, and phenol will be stronger than alcohol, right? So that's why I have shown here this electron donating group will destabilize the carboxylate anion and decrease acidity, and electron withdrawing group will stabilize carboxylate ion and increase acidity. So let us go to the next slide. So there are some problems, as I already discussed with you, that acetic acid, iodoacetic acid, bromoacetic acid, fluoroacetic acid and fluoroacetic acid, among these which one will be stronger, right? As you know, fluorine, chlorine, bromine, iodine, you go from top to bottom in the periodic table, you can find that electronegativity will what? Decrease. So during the beginning of the class, I told you that if the electronegativity of the element is more, that means it will have more electron withdrawing group. It will have more electron withdrawing effect. So acidity will increase. So among this, fluorine is the most strongest acid because its electronegativity is more than chlorine. So here iodine is the least electronegative, so and hence iodoacetic acid will be less acidic as compared to bromoacetic acid, chloro and fluoroacetic acid. And here fluoroacetic acid acidity will be maximum. Now you can tell that how we can compare this CH3 COOH versus chloroacetic acid. How we can compare this? Yeah, as I already discussed with you, plus I effect producing group, that is alkyl group, can decrease acidity, while minus I effect producing group, that is chlorine, can increase acidity. So this will be much more stronger acid as compared to acetic acid. That's why I have kept here acetic acid at first, and this is called as increasing order. So what do you mean by increasing order? Increasing order means what? From low to high. For example, 1, 2, 3, 4, 5, 6, 7, 8, like that. So the lowest value will be first and the highest value will be last in case of increasing order, right? So that's why I have written here that fluoroacetic acid is the strongest acid with lowest pH or pKa, while iodoacetic acid is the what? Weakest acid and highest pH. Similarly, you can also see if the number of chlorine atoms is more, then it will be more stronger. Acidity will be more stronger. Let us take one example. Suppose this one is the carboxylate anion, and if 2 chlorine is present, this will be the carboxylate anion, right? And if 3 chlorine is present, then this will be the carboxylate anion. Now you can clearly see that in the first example there is only what? There is only one electron withdrawing group, only one minus I effect. But in the second case there are 2 minus I effect, whereas in the third one there are 3 minus I effect. So obviously the minus I effect can increases acidity to carboxylic acid, and here this compound is called as trichloro. If you write the IUPAC name 1, 2, so at 2 position 3 chlorine is there. So 2, 2, 2 trichloro CHLORO acetic acid. So this trichloroacetic acid will be even much more stronger acid than monochloroethanoic acid or acetic acid, right? So Another thing is very important is that suppose if you have a trifluoroacetic acid, this is, you can see that due to the presence of 3 fluorine in carbon, there will be a strong electron withdrawing nature in the carboxylic acid, and you know that fluorine is the highest electronegative element in the periodic table. So this trifluoroacetic acid will be much more stronger, and you can say that its acidity will be as strong like inorganic acids. So if one drop of trifluoroacetic acid if fall into your hand, then you may require a plastic surgery to repair your skin. So this is as strong, very dangerous acid. So the short name of this acid is called as TFA. What is TFA? T for tri, F for fluoro, A for acetic acid. So trifluoroacetic acid is the strongest organic acid. Okay, so you can see clearly I have written this in order, increasing order of increasing order of their pKa, increasing order of pH, or so if you see the increasing order, then which one will be much more stronger among this? Which one will be much more stronger? Trifluoroacetic acid. Acidity will be maximum, right? So if you have I3C COOH, Br3 CCOOH, Cl3 COOH, and F3 COOH. Among this trifluoroacetic acid is the strongest acid among this, right? So but in terms of, if you ask to write the pH or pKa, which will have the highest pH? Obviously the acid which have the lowest acidity. So in terms of pKa, if you write, the maximum pKa will be for what? This, okay, triiodoacetic acid, because it is the weakest acid. Okay, so let us go to the next slide. So again I have written here, you can see the electron withdrawing group at ortho and para position can further increase the acidity in case of benzoic acid. For example, you can see if you write the structure of benzoic acid, you will see if in its aqueous solution, if you give water, you will get what? This benzoate, you will have this benzoate ion, plus you will get hydrogen ion. Again, this benzoate ion is again stabilized due to what? Resonance, right? So these benzoic acids are also acidic in nature, but if you have an electron withdrawing group at ortho and para position, it can increase its acidity. For example, here I have written here A, B, C, D, E, F. So we can tell that if electron withdrawing group is present, acidity is more. Nitro is electron withdrawing. Why nitro is electron withdrawing? Because in case of nitro group, you can see the presence of 3 electronegative elements. So as I already discussed with you, if number of electronegative element is more, acidity is also more. So you can tell that nitro group is an electron withdrawing group which can increase the acidity. So you can clearly see that in case of nitro group, it is electron withdrawing in nature, and hence acidity will be more, right? But here this OMe is a electron donating group, so its acidity will be less. So we can tell that presence of electron withdrawing group at the ortho and para position can what? Increase the acidity, while presence of electron donating group at ortho and para position can decrease the acidity. So here you can clearly see that this is benzoic acid B, which will be weaker than 2-nitrobenzoic acid. 2,4-dinitrobenzoic acid and 2,4,6-trinitro-benzoic acid. But this benzoic acid will be stronger acid than 2-methoxy-benzoic acid, where plus I effect producing group is there. So plus I effect producing group decreases acidity, due to which A will be least acidic than B. Okay. Now important question is what? At meta position there is less effect, right? But even though the nitro group is present, that's why it will be stronger acidic than benzoic acid. So we can write the order like this. A, as I already mentioned here, A will be what? Weakest acid. Why A will be weakest acid? Because electron donating group is present. Then benzoic acid, there is no group, so no neither plus I effect nor minus, but anyway it will be stronger acid than this. Then 3-nitro-benzoic acid, because meta position nitro group is present. Then 2-nitro-benzoic acid will be more stronger. 2,4, here 2 minus I effect producing group is there, and here 3 minus I effect producing group is there. So the acidity of 2,4,6-trinitro-benzoic acid will be more. Now you can ask that which one will have the highest pH or highest pK. Again the answer is what? The acid which is having lowest acidity will have highest pH or pKa. So this one will be highest pKa. Okay. So let us go to the next slide. So already I have mentioned here, in meta position, even though there is not much electronic effect, but due to the presence of electron withdrawing nitro group at meta benzoic acid, it is a stronger acid than what? Benzoic acid. So next we are going to discuss about the preparation of carboxylic acid. Anyway, as I already discussed with you that alcohol, if you oxidize, first you will get a what? Aldehyde. This reaction already we have discussed during the preparation of aldehyde. But another thing I discussed with you that if you want to convert alcohol to acid, you need a weaker oxidizing agent, because this alcohol can be further oxidized to form what? Carboxylic acid, right? So here two things you need to remember. If you want to convert alcohol to aldehyde, you need a weaker oxidizing agent like PCC, pyridinium chlorochromate. But if you want to convert alcohol to carboxylic acid, you need a stronger oxidizing agent like here potassium dichromate sulfuric acid. So it can convert this alcohol to aldehyde at first, and then this aldehyde will be again converted to carboxylic acid. So other examples are mentioned here. Here you can see that this ethanol, if you oxidize, at first you will get ethanal. It is an aldehyde, and then again this can undergo oxidation in presence of a what? Strong oxidizing agent to form what? Carboxylic acid. So this step to this step, I think you will understand, because here you can see CH3CHO, but here one oxygen is more, CH3COOH. So increase in oxygen, that means what? Oxidation. Increase in oxygen, we call it as what? Oxidation. But in this case what is happening here? Here removal of hydrogen is taking place. That's why also it is called as oxidation. So either removal of hydrogen or addition of oxygen, both are oxidation, right? In the first step there is a removal of hydrogen, in the second step there is addition of oxygen. So oxidation takes place to form carboxylic acid if you use a strong oxidizing agent. So if you have secondary alcohol, you will get a ketone, and again this ketone, if you oxidize, it will give a mixture of carboxylic acid. Here some CC cleavage will occur. Okay, so you get a mixture of carboxylic acid. So here I have written clearly, secondary alcohol on oxidation first produce ketone, which can undergo further oxidation to produce mixture of carboxylic acid. Let us go to the next slide. As I already discussed with you that carboxylic acids is having RCOOH. So if you carry out hydrolysis of nitrile. So these kinds of compound is called as nitrile, or also it is called as cyanide, or also it is called as cyanoalkane. So whenever you add water to this nitrile in presence of acid, first you will get an amide, and further this amide can generate carboxylic acid on further hydrolysis. So if you hydrolyze first, you will get first RCONH2, that is called as amide. It is a derivative of carboxylic acid. I discussed with you in the first lecture. So further hydrolysis, if you carry out, you will get a carboxylic acid, RCOOH. So this is one method. Another method is what? If you hydrolyze acid chloride, RCOCl, you know, it is also a derivative of carboxylic acid. So if you hydrolyze, that means if you add water to this acid chloride, here also you will get HCl will eliminate, and you will get what? RCOOH. That is also called as what? Carboxylic acid. So this is one method of preparation, and this is the another method of preparation. So these acid chloride are very reactive, right? So whenever you treat it with water, you will get carboxylic acid. Okay, so another one method, you can prepare carboxylic acid from acid anhydride even. What is acid anhydride? I already discussed with you in the first lecture. Here this acid anhydride, if you hydrolyze, you will get what? You will get carboxylic acid, right? So here H, here OH. If you see here one part carboxylic acid, you will get RCOOH, and another part you will get another RCOOH. So acidic anhydride on hydrolysis you will get what? Carboxylic acids, right? So this is I have shown here RCOCl, RCOOH. Okay, clear? On the other hand, if you have suppose this benzene ring, then this, then another benzene ring, if you hydrolyze, you will get what? Benzoic acid. Here also you can see like this. Here one part will be taken H, one part will take H to form COOH, another part will be also take H to form this what? COOH. So you will get a carboxylic acid, right? So next we are going to the next slide. It's one of the most important reaction in organic chemistry. दोस्तों ये reaction बहुत important है, इसको बोलते हैं Grignard reaction. So Grignard, for his contribution in the development of this particular type of reaction, have been awarded the prestigious Nobel Prize in chemistry. Okay, so let us discuss this reaction. So इसको बोलते हैं Grignard reagent, RMGX. So how this RMGX is prepared? When you take alkyl halide and magnesium in presence of dry ether, then you will get RMGX. So here you can clearly see this magnesium enters between R and X. Okay, so another thing you must know that why this Grignard reagent is prepared in dry ether. What do you mean by dry ether? That dry ether does not mean this ether is a solid. Dry means here this ether should be freed from moisture or water. तो ether में water नहीं होना चाहिए, ये pure ether होना पड़ेगा. So that should be purely ether. It should not contain any moisture. Why? Because if any moisture is present, Grignard reagent will be destroyed. कैसे destroy होगा? Let us explain. So one thing, let us take one example. Suppose CH3Br. Okay. CH3Br, when you will add magnesium and dry solvent, that is ether, here you can see that already I discussed with you that bromine is electronegative, so negative, it will become partial negative, and carbon is electropositive, it will have partial positive character. But whenever this CH3 will bind to metal, there will be a competition between metal and carbon, and metal will is always electropositive, so metal will win and metal becomes always positive, carbon becomes partial negative. Now you can clearly see that earlier carbon was positive, now the carbon is negative. So you can tell this polarity is changed from plus to minus, and this effect is called as Ampolong effect. Okay, so the reversal of polarity is called as Ampolong effect. So now you can clearly see that this CH3 is now becoming a what? Nucleophile, and also it can act as a base. So if any moisture is present in the solvent, what will happen? Let me to explain. This is negative, this is positive. If any moisture is present, then this can take up this proton and ultimately this electron will go here. Now if it takes up this proton CH3 negative, then it will become CH4 positive, plus you will get MgOH-Br. So this Grignard reagent, you can clearly see it will convert to what? Alkane. So it will be destroyed. Grignard reagent will not be retained in the reaction mixture. It will be destroyed to form alkane plus this magnesium OMG-Br. So that's why the preparation of Grignard reagent is always carried out in dry ether and under dry atmosphere. Okay, or also we call it as inert atmosphere. So yeah, it's a very important concept from alkyl halide. So you can see that this Grignard reagent can act as a nucleophile. Now here you know this is nothing but CO2, a simple carbon dioxide. Here I have shown with the help of this structure. Here you can see this carbon and oxygen. Here this also carbon and oxygen. But this is not too much reactive. But when you have Grignard reagent, then this R negative can come to this electrophilic carbon, and this electron can obviously go to oxygen because oxygen is electronegative and carbon is electropositive. So obviously this negative part will come to the positive part. So what will happen? This R negative will form a bond with carbon, as we can show with the red marked. So this bond will be formed between what? This carbon and Grignard reagent alkyl part. Okay, so you will have this electron will go to this oxygen, so this oxygen will become negative because this electron, when it comes to oxygen, oxygen will become negative. Now if oxygen is become negative, obviously it will be taken the what? Metal positive part. Next, again, if you hydrolyze this, then what will happen? This negative will take up this proton and this OH will go to this electron will be taken by this OH. So you can clearly tell that OH become OH negative and this O negative will become what? OH. So you will get carboxylic acid, and at the same time this negative will be taken by Mg positive to form MgOHX. So this is a very important reaction. Yes, here I have taken an example to explain you more better way. So you can see CH3MgBr, it is called as methyl magnesium bromide. When you react with carbonyl compound, this negative will come to this electron will go to this. So there will be a what? Bond between this carbon, you can see, and this carbon. That's why this is also called as carbon-carbon bond formation reaction. So Grignard reaction क्या होता है? Carbon-carbon bond formation reaction, right? So you can clearly see carbon-carbon bond formation. And further, this hydrolysis, again I already discussed with you, O negative can take up a proton to form this carboxylic acid. So as I already discussed with you, that why Grignard reaction is carried out in dry solvent, because if any moisture is present, then Grignard reagent will be what? Destroyed, as I already written here. I have already explained to you. So next I am going to the next slide. So our next is what? Physical properties. Yeah, physical properties, you know very well, the solubility, then what? Density. These are called as boiling point. These are what? Physical properties. Yeah, carboxylic acids are high boiling. Why? This is because of strong intermolecular hydrogen bonding. So when the hydrogen bonding occurs between two molecules, the two molecules will come closer to each other. So if the molecules come closer to each other, what will happen? You know that if the distance is low, force of attraction is more. If force of attraction is more, then what? It will require more energy to break the bond. That's why the boiling point will become increase. So carboxylic acid have high boiling point. Another thing, you can also tell that if the molecule come closer and closer to each other, then the density will increase or population will increase. So carboxylic acids have comparatively higher density as compared to other hydrocarbons like alcohol. So this is called as association. What? This is called as association, which you have already studied in your colligative property, that what? Solutions chapter, right? So when two molecules of carboxylic acids is present, then you can clearly see hydrogen bonding between these two electronegative oxygen can occur. Here also you can clearly observe hydrogen bonding. So due to this, they are forming a dimer. What is dimer? When two molecules combine and form one molecule, it is called as dimer. So due to this dimerization, because of strong intermolecular hydrogen bonding, carboxylic acids have higher boiling point, carboxylic acid have higher density, and this is the reason is nothing but intermolecular hydrogen bonding. Similarly, you can also tell that why carboxylic acid will be soluble in water. Again, the reason is same. It can form what? Hydrogen bond with water. So any compound, if it can form hydrogen bond with water, it will be soluble, right? So carboxylic acid has two oxygen, so it can form more hydrogen bonding with water. That's why they may be soluble. But one point is sure, if this alkyl group is bigger, that means for higher counterpart, acidic counterpart, the solubility will decrease, right? Because of steric repulsion. This is another important point. You can study from your NCERT book. So next is what already I discussed with you, solubility. So next is a very important concept, that is called as what type of chemical properties chemical reaction will be shown by carboxylic acid. Yes, carboxylic acids can show what? Some of the important reaction like esterification reaction. What is ester? Ester is a sweet smelling organic compound. They are also present in some fruits like some of the fruits have this ester, so that's why they have pleasant smell. They can be also used as perfume, right? So ester is a sweet smelling organic compound. Now how this ester is formed? Again, maybe you have studied in your alcohol chapter that when alcohol is react with carboxylic acid, you will get what? Ester. Okay, so you can also remember this reaction like this, but although the mechanism is slightly different, I am not going to details the details in the what mechanistic part in the short lecture. Suppose this is a alcohol and this is a ester. Suppose this is R dash. You can clearly see that some elimination of water molecule will occur, and ultimately you will get RCO R dash. This is ester. This is a reversible reaction. Reversible reaction मतलब क्या होता है? A acid is treated with alcohol, you will get ester and water. Ester is having sweet smell, as I already discussed with you. Sweet smell. Now, if you react ester plus water, you will get acid plus alcohol. तो reversible क्या होता है? Alcohol और acid react करने से ester और water. अगर ester और water, that means hydrolysis of ester, you will get back acid and alcohol. So this is one of the common reaction. And another reaction is what? Electrophilic substitution, which I already discussed during my last class. That is aromatic electrophilic substitution. Here one electrophile is generated. Nitro group is acting as an electrophile. Now one thing you always remember, that if any electron withdrawing group is present, like carboxylic acid, which has a 2 oxygen atom, that is -I, then it will be meta directing to electrophil. So electrophil will come at what? Meta position. But on the contrary, if phenol is present, phenol is ortho para directing. In case of phenol, maybe you have studied this reaction. Whenever you carry out nitration with dilute nitric acid and concentrate dilute sulfuric acid, you will have nitronium ion, but in this case this phenol is ortho para directing. You will get product at what? Ortho and para position. So this is very important. You always keep in mind that if any electron donating group is present, then you have para and ortho isomer, and if you have electron withdrawing effect like minus I effect, you will have meta isomer. So you will get meta nitrobenzoic acid, or also you can tell, if you number it 1, 2, 3, you will have 3 nitrobenzoic acid, right? So these two reactions already I explained to you. So next I am going to the next slide. Okay. Yeah, this here you can see this hydrogen that is replaced by this nitronium ion, which is acting as the electrophil in this case, right? So next is what? This Hall-Horler-Zielinski reaction. This is also one of the most important reaction. It is, you can say, as I already discussed in the last class, what is alpha and beta? This is a functional group. So if this is a functional group with respect to first position, that is called as alpha. Here you can clearly see 2 hydrogen atoms are present. So if any alpha hydrogen is present, that will undergo halogenation in presence of bromine and red phosphorus. This is called as Hall-Horler-Zielinski reaction. In short form, it is called as HVZ reaction. So this, what is HVZ reaction? It is nothing but alpha halogenation. So as I have given more and more example here, you can see these alpha hydrogen will be replaced by chlorine if you give red phosphorus and chlorine. If you give red phosphorus and chlorine, here also this chlorine will replace, and if you give red phosphorus and bromine, you will get here bromine. So in this position you will get what? Bromine if you give what? Red phosphorus and bromine, right? So this is called as halogenation reaction, where X may be chlorine or bromine. Dear students, please you study all this material, and after you study all this material, in the last lecture, that is lecture number 4, I am going to discuss some important problems from organic chemistry. These are the most important problems. So you will be able to solve this problem only after you study these 3 lectures. Thank you very much.